The electrical system can look complicated, but don't worry, we'll only cover what you need to know to operate the system. We won't go into detailed circuit diagrams, and you won't be expected to remember what is powered by what, or deal with abnormal checklists from memory. The electrical generation and distribution system provides 28-volt DC power from a starter generator on each engine, monitored and controlled by a generator control unit from an optional auxiliary power unit generator, from 3 batteries, a 24-volt main and auxiliary battery rated at 40 ampere hours, and a standby battery rated at either 17 or 40 ampere hours, from the left and right transformer rectifier units, TRUs, fed from the AC generators, and of course from DC external power. There is also one AC system linked to the DC. The AC power sources are an AC generator mounted on the prop gearbox of each engine, which provides 115-volt 3-phase variable frequency AC through an AC generator control unit to the 2 TRUs, which in turn supply the 28-volt DC system. AC external 115-volt 400 Hz power can also be connected. The AC system powers these consumers. Let's look at how the electrical system links together, starting with the DC system. The standby battery permanently powers a battery bus, which provides emergency power even when the rest of the electrical system is unpowered. The auxiliary and main batteries power the left and right essential buses, interconnected via a circuit breaker, and the standby battery also powers the left essential bus. The battery bus is always on, but the essential buses are directly connected to the battery master switch and are only powered when the switch is in the battery master position. The starter generator mounted on each engine accessory gearbox serves as a starter motor, then converts to a DC generator when the engine is up to speed. The generator control units protect the electrical system from overvoltage, overcurrent and reverse current. Even though engine speed and electrical loads will change, the GCUs give a fixed 28-volt DC supply when their Gen 1 and Gen 2 switches are on, to the left and right main feeder buses, sometimes called main buses, to the main distribution buses, and to the essential buses. The main buses also charge the batteries, provided that the standby, auxiliary and main feeder switches are on. When they're off, you get the battery caution lights indicating that the batteries are not being recharged. When the external power switch is on, DC external power feeds into the left main feeder bus only. If an APU is installed, it feeds into the right main feeder bus only. Now linking in the AC system. When the prop is unfeathered, the AC generators come online. AC generator control units monitor voltage and frequency output and provide automatic bus tie and bus fault protection. With the AC generator switches closed, the left and right variable AC buses are powered. The variable buses also supply the galley buses, the left and right transformer rectifier units, TRUs, that transform AC to DC, and power the secondary feeder buses, then the secondary distribution buses. AC external power is connected into both variable AC buses and can power the TRUs before the AC generators come online. AC cross-tie operation in the event of a generator or bus fault is controlled automatically by the AC GCUs. In the DC system, there are 4 bus ties, the main and secondary, called the horizontal bus ties, and you've guessed it, the left and right, called the vertical bus ties. The vertical bus ties will be open when the TRUs are producing DC, and closed when the TRUs are unpowered. Control of the DC bus ties is largely automatic via the Electrical Power Control Unit, EPCU. The EPCU monitors the DC electrical system and contains logic that automatically reconfigures the power flow in the event of a failure in one or two of the four power sources, 2 DC generators and 2 TRUs. If 3 power sources fail, the EPCU provides automatic load shedding. It also communicates with the engine and system integrated display to display the status of the electrical system, and with the crew alerting system to trigger warnings and cautions. There is also a manual bus tie switch which can be used to advise the EPCU, but the EPCU will override invalid combinations. This manual switch functions mainly as a backup if the EPCU itself loses power. We'll show operation of the EPCU with different power sources in the normal and abnormal lessons.